Hello, my name is Halil Akgül. I'm a freshman student in the Computer Science department at Bilkent University. Today, I will present my Physics 101 lab final project, analysis of simple pendulum and the large angle motion. The objective of this experiment was to validate the experimental setup by calculating pi and to analyze how the period changes at large angles. For the setup, I used a rigid metal stand, a fishing line with a fixed length of 0.90 meters and a dense metal bob. I also used a protractor to measure the release angles precisely. In the first part of my experiment, I focused on validation. I released the pendulum from a small angle of 5 degrees. Since a small angle approximation holds true here, the period should be constant. I measured the time for 10 oscillations and averaged the results. Using the average period of 1.88 seconds and the length of 0.90 meters, I calculated the experimental value of pi as 3.103. When compared to the accepted value of 3.14, my percentage error was only 1.23%. This low error proved that my setup was stable and accurate. After validating the system, I moved to the main analysis. I repeated the experiment for larger angles, 10, 20, 30, 45 and 60 degrees. I wanted to see if the period would stay the same as the standard theory suggests. The results were clear. While the period was stable at small angles, it started to increase significantly as the angle grew. At 5 degrees, the period was 1.88 seconds, but at 60 degrees, it increased to 2.014 seconds. This showed that the standard formula fails at large amplitudes. To explain this deviation, I used the large angle approximation formula. This formula includes a correction term for the amplitude. For example, for 60 degrees, the theoretical period is calculated as 2.033 seconds. My experimental result of 2.014 seconds is very close to this prediction. We can see this behavior clearly in the graph. The orange line is the ideal simple harmonic motion, which is flat. My data shown as blue dots follows the green curve, which represents the large angle theory. This visually confirms that as the amplitude increases, the period also increases. To conclude, let's look at what we expect versus what actually happened. According to the simple harmonic motion theory, we expected the period to remain constant regardless of the release angle. However, my experimental data proved that this holds true only for small angles. As we exceeded 15 degrees, the period didn't stay constant. Instead, it increases significantly, reaching 2.014 seconds at 60 degrees. This deviation confirms that the small angle approximation fails at the large amplitudes. So we can clearly say that for the large amplitudes, we cannot ignore the initial angle. Thank you for watching.